Welcome back, everybody. So in the last video, we looked at lab procedures and how to reproduce basically Darcy's experiment with a constant head permeameter, a simple, homemade constant head permeameter, as well as a falling head permeameter, and we collected a bunch of data. And so today I want to show you basically the original data from Darcy, and then for your homework you'll have to analyze the data from Darcy itself, and then the data collected in the lab, and calculate hydraulic conductivity for different materials or in different cases. Okay, so let's take a look. Again, a quick reminder of the apparatus from Darcy. You already saw it when we did the lecture on permeameters a couple of lectures back. So it was a foot in diameter, 35 centimeters, so quite a large column, 2.5 meter high, and you could fit up to 1.7 meters of sand. So you could have a sand column here, up to 1.7 meters. So quite the column experiment. So the results for 5 experiments that he conducted a lot more obviously, but 5 of his experiments, he actually reproduced the results, the data, in his book, in an appendix of his book, and that's where I went to get them and put them in a spreadsheet that you have for your homework. And here's just a snapshot of the first experiment here, the second, and then 3, 4, 5 are below it in the spreadsheet. And you can see that there's different tests, right? So in this first experiment, for example, the length of the packed sand is 0.58 meters, so 58 centimeters of column of sand. This is the data collected, so the flow rate, the Q out basically, so in liters per minute. The head at the inlet, so you can see in this experiment he varies the head at the inlet, because again the goal is to plot basically Q versus head, right, head gradient. And then the head at the outlet is 0, so basically the head is just the inlet head. Now if we plot this data together, right, so this is the data similar to the one we collected yesterday. So now we have flow versus head. Now if we plot this for this first experiment, this is the result, right? And that elucidate, whether the relationship is linear or not, right? So that was our hypothesis. If you remember a couple lectures back on the permeameters, I said, you can hypothesize that this is linear. And now we have a slope, right, that gives us the hydraulic conductivity. So again, if we remember, Q equals A H L. Okay, so now if we plot Q over A versus H over L, as we have here, right, the slope will be K. In this case, I just plotted the raw flow versus head. If you plot flow over A versus head over L, right, then the slope is the hydraulic conductivity. So that's what you want to do for the homework. Okay, and here's a look at all the experiments, and you can see that some of them are really on top of each other, and some of them are slightly different slopes. And one of the goals of the homework is sort of discuss why you think the slope might be slightly different. Did we use like different materials, for example, different sands, or what happens here? Because in theory they should all be, if they come from the same material, right, they should have the same slope. And this is really important because K, hydraulic conductivity, really is a property of the sand itself, of the material, not really of the fluid. Although we'll see in the next lectures when we go back to the fundamentals and sort of derive Darcy's law from physics principles, basically, we'll see how the property of the fluid also influences the hydraulic conductivity. In other words, if you have honey versus water flowing through the exact same gravel, obviously the honey is going to flow slower, so hydraulic conductivity will be different. So it's a property of the material mostly if we're talking about water, right? But depending on the viscosity, you might have differences, and we'll talk about this again later in those lectures. Okay, so this is just, this was just a quick sort of technical note to show you how to plot the data, remind you, what to plot on the y and x axis to get basically the hydraulic conductivity for the homework. Okay, thank you.